Tech. I suppose this job isn't too complicated, but I've never had much experience on checking an air conditioning system.
Well, you can relax, Dave. Air conditioning service is simple. Now, suppose we wait until Tom gets off that phone so the three of us can talk it over.
Okay, if you say so, Tech, but I did want to get a head start on this job.
Boy, that's a switch. First time I knew you wanted to get a head start on anything besides the rest of the gang when the quitting whistle blows.
Hey, looks like I'm just in time to break up a fight.
Not really, Tom. Dave asked about air conditioning, and I was stalling him off until you finished answering the phone.
Well, good. I didn't want Dave to feel I left him in the boat by himself. I know he's rusty on the subject. Maybe a good review is what we ought to tackle.
That's music to my ears, Tom. A good review is exactly what I need.
You're not alone there, Davy boy. A lot of fellas like you can stand some brushing up on air conditioning service. It's not so tough if you just use your head.
Okay, then, Dave. Suppose we talk about the three main phases of air conditioning service. First of all, for instance, there's how much the owner knows about working the controls.
You don't really mean that, do you?
He sure does. Look, a lot of owners don't really know how to operate the controls to get the most out of air conditioning. Sometimes that's actually all that's wrong.
Right. Second, there's the air circulation part of the system. We have to see if the blowers are moving the air around properly. Finally, there's the refrigeration part of the system. Is it doing the cooling job?
I see. And there's control know-how, circulation, and cooling.
That's it in a nutshell, Dave. And never pass up a chance to wise up the owner on those controls.
Good advice, Tech. Believe it or not, but I've seen some cases where the owner failed to turn the temperature control on. He just turned the blower on. As a result, he didn't get any cooling from the unit. And some don't even know how to use the system in the winter.
Winter? Are you serious?
I sure am. Circulation's important in the winter. You might want to remove odors without opening the windows. On cold, damp days, you might want to lower inside humidity to keep all the window glass clear. What's more, you can tailor the circulation to your own taste. You know the blower switch controls air circulation. You can vary the blowing speeds from low to high or in between.
On hot days, you can control how much heat you want removed. The temperature control dial has an off, cold, and cool position. On cold, and with the blower set at a high-speed position, you get maximum cooling.
You don't suppose that would be too cold, would it?
Well, it all depends, Dave. Some owners can stand it, some can't, but all of them can regulate it to suit themselves. Now, if a car's been parked in the hot sun all day, you'd want a fast cool-down job, and to do that, you set the temperature control on cold, leave the blower on low, start the engine, and roll down the windows. Drive a few blocks to draw off the oven hot air, then close the windows and turn the blower dial to a high speed. In a few minutes, inside temperature will be down to where it's comfortable.
Not bad, Tom. Not bad at all. I know how hot a sun-parked car can get.
Something else you ought to know, Dave, is what to do when an owner who knows how to work the unit reports that it isn't working satisfactorily.
I second the motion. And the easiest check to make first is on blower operation. A circulation check, in other words.
Oh? And how's that supposed to be done?
Well, first run the blower in each of its three operating positions. See if there's a definite change in operation and circulation. If so, the blower control and motor are okay. If you get only two speeds, check the blower motor resistor assembly. It's in the engine compartment on the left side.
Oh, incidentally, Dave, different make resistors have been used, and they're wired differently. So try reversing the red and black wires at the resistor terminals and check the blower speeds again. Usually reversing the leads corrects the condition.
But what if the blower doesn't work at all?
Well, in that case, Dave, you'd check out the whole electrical circuit from blower switch to circuit breaker, resistor block assembly, and to the blower motor. Check for shorts, high resistance, loose or open connections. You can follow the wiring diagram for the model you're working on.
Well, the blower on this car must be all right. I did get 3 different blower operations.
That's fine, my boy, but don't overlook the possibility of reduced airflow.
Tech's right. You might get variations in blower speeds, but the flow of air could be cut down due to slow blower speeds or a restriction between the inlet and outlet grills. Loose or corroded electrical connections causing high resistance can cause a blower to loaf along much slower than normal. You can tell by the sound whether the blower is running as fast as it should. There should be no more than a total of 0.2 voltage drop from the battery to the blower motor. Check voltage drop with a fully charged battery and the blower switch on high.
If you ever have to replace a unit, be sure you get 12-volt units in a 12-volt system and 6-volt parts in a 6-volt system.
Okay, Tech. I'll watch out for that.
Good. Now, on a 1955 model, if the blowers work okay, but there seems to be reduced air circulation, check the insulation inside the evaporator unit. Now, to do this right, remove the air inlet grills and see if the insulation has worked itself loose and is resting on the coils. If it has, use rubber cement to re-cement it in place. A clogged air filter can also restrict airflow. Check it about once a month and more frequently if the car is operated under extremely dusty conditions. Replace a dirty or clogged filter.
Is that about it on checking circulation problems?
Yeah, Dave. So let's talk about the cooling job done by the three main parts of the system: the evaporator, the compressor, and the condenser.
Well, basically, don't those three units circulate the refrigerant through the system so as it can take heat from inside and dump it outside the car?
Precisely, my boy. And that refrigerant works on the cooling by evaporation principle.
Well, maybe so, Tech. You can't prove it by me. What's that supposed to mean?
Well, Dave, did you ever notice what happens to a drop of alcohol in your hand? You wave your hand around and the alcohol evaporates. As it evaporates, the spot where it was feels cool. In our air temp system, instead of alcohol, a refrigerant is used. The compressor moves refrigerant through the system so it can pick up heat at the evaporator and transfer the heat to outside air at the condenser. The compressor pulls heat-bearing refrigerant from the evaporator, compresses it, and sends it to the condenser in hotter, pressurized form. That helps it lose heat more quickly to the surrounding air.
As the compressed refrigerant gas gives up its heat, it changes back to a liquid. Then it goes through a receiver-dryer-strainer and back to the evaporator.
Oh, I remember now. Hot air from inside the car is circulated around the evaporator coils by the blowers, so the refrigerant can again pick up the heat.
Right. Now, if somebody will please turn this record, we'll go into how to check the cooling job done by the system.
If an owner reports that the air conditioning system isn't cooling as much as it should, you can check it easily with a road test. But before you go out, mount a thermometer at the air inlet grill and another thermometer at the air outlet grill. Turn the temperature control on cold and the blower control to high. Then, with the windows and the fresh air vent handles in the luggage compartment closed, drive the car at 25 miles an hour.
Okay, but what are you trying to prove?
You're trying to see if the temperature at the outlet grill is 23 to 25 degrees lower than the temperature at the inlet grill.
Right, and while that temperature difference may vary depending on the inlet temperature, a temperature difference of less than 23 degrees usually means the system is not cooling properly. But even if you get the right difference, the owner might not feel cool enough if the volume of air isn't right.
I get it. Now, on our car, the air volume or the circulation seems to be okay. But suppose we didn't get enough temperature difference. Where would we look for the cause?
Good question, Dave. And Tom's the boy who can tell you.
Well, first of all, Dave, you should check the sight glass. It should be perfectly clear of bubbles after the system's been operating with the temperature switch on cold for more than 7 minutes.
And if I do see bubbles?
Well, it means the system is low on refrigerant. So test for leaks. Correct any you find and recharge the system. Check the plate on the compressor to be sure you use the correct refrigerant.
Okay. Now, where do we go from there?
Well, next you should make sure the refrigerant is circulating. So see that the compressor belts are properly adjusted and don't slip. You'll know a belt is right if it meets the specifications given in the reference book. The belt deflection varies a little depending on the make and model of the car. And by the way, if it's necessary to replace a belt, replace both of them. Don't run a new belt with an old one.
The belts on this car appear to be all right. What's next?
Next, we should see if the magnetic clutch engages when the temperature control switch is turned on.
Good point, Tom. Now the front pulley will freewheel without driving a compressor if the temperature control switch is off or the clutch isn't working right.
Right. And if the compressor pulley is running, but the magnetic clutch doesn't drive the compressor, you'd better check the brushes for proper seating. They may be worn or burned. Besides that, check the slip rings to make sure there's no burning from arcing on the part of the brushes. You can reface a slip ring in a lathe if it's burned.
Above all, Dave, be sure the electrical circuit from the switch to the brushes is complete.
Okay. I can see how that would be important.
And keep in mind that poor cooling at high speed can very often be traced to clutch slippage.
Suppose our clutch and compressor's working okay. What should we look for then?
Look for restrictions, Dave. Kinks in the line from compressor to the condenser, for instance.
Yeah, and make sure the condenser fins are free of bugs or other particles. How well the condenser works depends on how freely outside air can pass through the fins. Use a soft bristle brush to clean the fins. Check for kinks in the lines to and from the condenser. And look that receiver-drierer-strainer over, too. That unit, you know, receives and stores refrigerant, absorbs moisture, and filters out any foreign material. Normally, liquid refrigerant goes through the receiver-drierer-strainer with no change in temperature. But if it gets plugged, the refrigerant will cool down on the way through.
Use both hands to compare temperatures at both ends of the receiver unit, Dave. If there is a difference, replace the unit.
Okay, will do. Now, what's the next checkpoint?
The solenoid valve, Dave. It's in the line running along the fender panel and does an important control job. I think Tom ought to tell you what the valve does.
That's a good suggestion. With the temperature control on cool, the system operates at less than full cooling. This reduction occurs whenever the solenoid valve is de-energized and remains open. An open solenoid valve lets part of the hot, high-pressure gas from the compressor mix with liquid refrigerant entering the evaporator coils. This cuts down the heat absorption rate of the evaporator, and air returned will be cool rather than cold. Now, there's a second control called a thermal switch in the system, which opens the solenoid valve when the evaporator gets too cold.
How could the evaporator get too cold?
Well, if the blower is on low and the temperature control is on cold, the evaporator can collect frost, which may restrict air circulation. That's where the thermal switch gets in the act. It's wired in series with the temperature control switch. If gas leaving the evaporator cools down to the frosting point, the thermal switch opens. This de-energizes the solenoid valve, and it opens, cutting down the cooling capacity by bypassing hot gas to the liquid refrigerant entering the evaporator. When gas leaving the evaporator warms up above the frost point, the thermal switch points close. This, in turn, closes the solenoid valve, which shuts off the bypass. The system then returns to full cooling.
Knowing how that works, Dave, will help you check solenoid operation.
Yeah, and just remember that the solenoid valve is normally open. In addition, it's magnetically closed when the temperature control is turned to its coldest setting. Also, to prevent coil frosting, the thermal switch can override the coldest setting by opening the circuit to the solenoid valve.
I understand how it works now. Does that about finish our checks on cooling?
Not quite, my boy. There's still the expansion valve to look at. Eh, Tom?
Yeah, Tech's right. The expansion valve at the evaporator feeds the right amount of liquid refrigerant into the coils.
The right amount?
That's right. Enough liquid refrigerant must be fed in without flooding and without starving the evaporator. Too little liquid means it'll all change to gas and be warmer than normal as it leaves the evaporator. A thermal sensing bulb at the outlet side of the evaporator controls this. It's connected to the expansion valve by means of a small sealed capillary tube. If the gas leaving the evaporator gets too warm, the bulb sends pressure through its tube to the expansion valve. Inside the valve, this pressure moves a diaphragm, which opens the valve, increasing the flow of liquid refrigerant until the right amount is fed into the evaporator.
Yeah, Dave, and the valve won't work right unless the bulb makes good thermal contact with the suction manifold, and unless the capillary tube is unrestricted.
Poor bulb contact or a damaged capillary tube will cause no cooling, poor cooling, or erratic cooling.
I see. Well, how do you check for those?
Well, checking bulb contact is simple. It's wedged against the manifold by two copper or bronze strips. If you can wiggle the bulb easily, it's not making good contact. So to improve it, just use a thin, clean copper strip and re-wedge the bulb for better contact. One more thing to do is check for kinks in the suction gas line from the evaporator to the compressor. It's the large diameter line. You can't miss it. Well, now, that just about covers how anybody can check the system and correct the more common causes that affect operation. You don't have to be an air conditioning expert to do the things we've talked about.
About the only things we haven't touched are the superheat spring and the suction pressure equalizer tube.
What are those and how do they work?
Well, there's something you don't have to worry about yet. If you ever find trouble and need to make further tests on the refrigeration end, however, you'll need special tools and a thorough knowledge of the system. So this reference book covers that advanced information. How to make a compressor capacity test, thermal switch and solenoid test, and a superheat test are all spelled out.
Great, Tom. That book's going to be a real big help.
Fine, Dave. And remember, when you get into that phase of the work, just go slowly. Follow instructions and don't jump into unit replacement until you're absolutely sure it's necessary.
Right, Tom. If Dave and all of our mechanics do that, we'll give our owners top air conditioning service. Believe me, customers appreciate that.